Everyone, and welcome to the next part of lesson 23.2. This is going to be part 4 in dealing with deriving and using our half-angle identities. So the half-angle identities can actually be derived from the double-angle identities that we've been working with for the past few days. Now, our half-angle identities are going to be found when we take the original identity here and solve so that we get cosine of theta isolated. So right now, in order to start solving this to get cosine of theta by itself, we're going to start by adding 1 to our identity. And I'm just going to add the 1 over here, and this equals 2 cosine squared theta. And then we're going to divide everything by 2. And eventually we're going to have to square root. So what ends up happening to get this cosine of theta completely alone, now the cosine of theta is alone, and on the left-hand side, or I now moved to the right-hand side, we have positive or negative square root of 1 plus cosine of 2 theta, all divided by 2. Now, where does the half-angle portion of this come in, right? Here's the second part entirely. Let's let 2 theta equal alpha, and let's isolate theta to be by itself. So if we divide both sides by 2, we end up with alpha divided by 2. Now from here, if we substitute in for our theta value, the alpha divided by 2, so again, if we're going to put things in terms of our theta value, so we have cosine theta from here. If we just bring that back over, instead of saying theta, we're now going to say alpha divided by 2, and that's going to equal positive or negative square root 1 plus cosine of 2 times alpha, which 2 times alpha is now 2 times alpha over 2, or excuse me, theta is not that. Well, that cancels out. We're just left with alpha all divided by 2. Okay, so this is the half-angle formula for cosine. Now the sine can be derived in a very similar fashion. Okay, so with sine, we know that cosine of alpha equals 1 minus 2 sine squared. And then again, alpha is divided by 2. Okay, so, and this is just substituting in instead of saying 2 theta, right? 2 theta. We're now just canceling some of these out, right? So that's all that's happening there. And again, if we rearrange this so that the sine of alpha divided by 2 is by itself, we would have to subtract the 1 and then divide by the negative 2. We end up with, when we divide by negative 2, cancels, and we can reorder this so that we end up with positive 1 minus cosine theta, all divided by 2, just bringing that up, kind of distributing it through. And then we end up with sine squared of alpha divided by 2. And then finally, when we square root, we end up with sine of alpha divided by 2 equals plus or minus our 1 minus cos theta all over 2. So here's kind of our second formula, this time for sine's half angle. Now finally, we can also derive tangent using the half angle formula and thinking of tangent as sine of alpha divided by 2 divided by cosine of alpha divided by 2. Because from there, we can just kind of plug in what we found from above, that sine is 1 minus cos over 2 divided by plus or minus square root of 1 plus cos theta, or alpha, divided by 2. And we know that we can make this 1 square root into, or these 2 square roots into 1 giant square root. And then for the fraction within a fraction, the 2's cancel. And we're just left with 1 big plus or minus, where it's 1 minus cos on the top, and then 1 plus cos alpha on the bottom. Okay, so that's our third one for tangent of alpha divided by 2, our halving. Okay, so in summary, I know that was probably 5 or 6 minutes of listening. We have our half-angled identities. So again, we can think about values that we know the exact value of. And when we divide them by 2, now we can find those values as well using the half angle formula. So the first example here asks us to find the exact value of sine of negative 15, okay? So think about what value in quadrant 4 and quadrant negative 1 divided by 2 is negative 15. That's negative 30, and that's a value we do know the formula for. So since it's in quadrant 4, sine is negative there, right? Sine of negative 15 is negative there. So that's why we decide on the negative out front here as opposed to the positive when we have the plus or minus. We're choosing negative this time. And then we're plugging in negative 30, the value that we get when we divide by 2, and using the cosine of that to plug in. And then to simplify everything, multiply everything by 2, and then square root top, square root bottom. This is how you are going to leave your answer for the half angle identities, okay? So from all of these, you're kind of thinking, what value on my unit circle when I divide it by 2 is going to give me this exact value? So you'll see on the top of page 312, these 3 examples here. Now, fair warning, they don't give you a lot of room to write these. So I recommend over in the My Notes section writing this. But for the first one, cosine of pi over 8. What value on our unit circle divided by 2 is pi over 8? Well, that's pi over 4. So that's what we're going to use when we plug into our handy dandy cosine formula. We're going to do 1 plus cosine of pi over 4. Again, the value we do know. And then divide that value by 2. Now, cosine is positive in quadrant 1, right? At pi over 8. So that's why we know we want a plus sign out front here. So from there, we're going to say, okay, 1 plus the cosine of pi over 4, which is square root of 2 over 2, all divided by 2. And then kind of to get rid of this fractional value of 2 down here, if we multiply everything by 2, we get rid of that fraction within a fraction. And this just becomes square root of 2 over 4. And then finally, we can just make this 1 square root into 2 so that we get the numerator as square root of 2 plus square root 2. And then square root of 4 is just 2. Now, the next one is tangent of 15. So again, we're thinking what value divided by 2 would be 15 that we do know the value of? Well, that's 30 degrees this time. And tangent at 15 degrees is a positive value. So we know it's going to be the positive square root on this one. And then 1 minus cos 30, all divided by 1 plus cos 30. And we end up with plus sign. Cosine of 30 degrees is the square root of 3 over 2. So we have that for both the top and the bottom. And then again, since we're dealing with the fraction within a fraction, we're going to multiply everything by a 2. And we end up with 2 minus the square root of 3 in the numerator, 2 plus the square root of 3 in the denominator. And honestly, this is as simplified as this one's going to get. They're not going to make you do any other crazy rationalizing, which is really nice. You can leave your answer like this, and we'll just leave it as so, okay? Now, finally, for the last example of today, we have sine of 13 pi over 12. Now, again, you always have the option, once again, of creating, looking at converting this to degrees if necessary, if you don't like dealing with radians. But we know that sine of 13 pi over 12 is really going to be the same as saying sine of 13 pi over 6 divided by 2. And 13 pi over 6 is actually sine of pi over 6, right? They're coterminal values, so it's the same thing, all divided by 2, okay? Or again, feel free to convert this to degrees by multiplying by 180 over pi. And again, it'll give you the same answer. But dealing with radians, just so we have some practice as well. Okay, so again, 13 pi over 6 divided by 2 would be the 13 pi over 12, but we'll use the coterminal value of pi over 6. Okay, so for sine, this time we have to be aware that if we are talking about pi over 6, the sine value here of pi over 6 is a positive value in quadrant 1. Excuse me, 13 pi over 12 is actually what we're going off of, though. So 13 pi over 12 here, when we're trying to decide is this positive or is this negative, 13 pi over 12 is actually a quadrant 3 value. So despite this being a quadrant 1 value, that's not what we're taking into consideration when we have out front, is this positive or is this negative? Because this is in quadrant 3, sine is negative there. So always go back to the original when you're trying to decide, is this square root positive or negative that we're using? Now, when we actually plug in then to the values, we have 1 minus cosine, careful with the sign, it's always in terms of cosines, pi over 6, all divided by 2. And this time the pi over 6 is square root of 3 over 2 divided by 2. Everything gets multiplied by a 2, and we end up with negative square root 2 minus square root 3 all over 4, which finally is negative square root of 2 minus square root 3 over 2. Okay, so the biggest thing you need to be careful of is when deciding, am I using the positive or the negative? It all goes into what question you're being asked for. And like this last one, even though pi over 6 was positive in quadrant 1, you would use negative because we're going off of the original question. Okay. Okay, there's a whole nother part to this that we will look at with dealing with drawing our reference triangles and comparing those values, similar to what we've done with the sum of difference in double angle. But for now, make sure you have these formulas written down, and we'll work more with them in class. Thanks, everyone.